Okay, first off, welcome everyone, and thanks for attending our latest petroleum industry webinar. Just quick introductions. You might not recognize it from the photo because that's obviously pre-quarantine, but I'm Baker Wallace, an account manager on the Esri Petroleum team, and I'm joined by my solution engineer, Matt Ballard, and of course, a fan favorite, Tiffany Glenn, who's going to be helping us out to manage the questions and comment sessions. So to get started, I'm going to take about 10 minutes to talk about the expansion of our digital twin and how we can expand that digital twin by incorporating real-time and IoT data to bring more value to our business. This will lead to the introduction of a new product, ArcGIS Velocity. And then the exciting part, Matt is going to walk us through a live demonstration to show how ArcGIS Velocity can be leveraged real-time data to improve operational efficiencies. And of course, we're aiming to leave some time at the end for questions. So please put those questions in the questions box because we don't want you to forget. And as I said, at the end, we'll address those. All right, so in today's webinar, we're going to continue our theme of talking about ArcGIS and how its unique role in creating a digital twin of our world. In the past webinar, Beyond Points on a Map, our friends Adam Pittman and Matt Ballard talked about building a digital visualization of our world. Today, we're going to take that one step further by integrating real-time IoT data into our digital twin. Now, all technology companies today will talk about digital transformation. It's a term that has been on business headlines for years. Last year, however, digital transformation became an absolute necessity. With the coronavirus pandemic, we've been forced to meet this evolution head on, as the personal and professional worlds have likely been changed forever. While there are many different softwares and technologies that play an important role in digital transformation, Esri has its own unique and critical space in this conversation. A unique space that fundamentally differs itself from other technologies. Because at Esri, we focus on the power of location, providing geographic context and transforming our world by building a true digital twin, accurately representative of our assets in our world. So, as I said before, we've all been working towards this visualization of our digital twin for some time, making the step to take things from points, lines, and polygons on a map to integrating engineering-grade schematics with 3D orthomosaics and bringing CAD and BIM drawings of facilities into 3D scenes to build accurate representations of our assets. Our digital twin is beginning to look like our real-world assets. Having that accurate visual of your digital twin brings huge value to an organization and being able to see a true field view of your assets. This helps with planning, design, inspections, and so forth. But an accurate visual of your digital twin is just one piece of the puzzle. As we all know, the world is increasingly connected. Way beyond computer systems and phones, we're now down to devices and sensors that are increasingly diverse. Studies suggest that soon there's going to be over 20 billion connected things in our world. And while many of these may be consumer focused, there's also a huge growth in devices that support industry and business applications. There's a variety of reasons for this explosion in connected devices. Devices are becoming cheaper, allowing more organizations to purchase and deploy them at less cost. You may have noticed this, as well pads are commonly becoming Wi-Fi enabled. That's because these devices are also becoming smarter, allowing people and businesses to not only record observations, but also to perform actions and trigger alerts based on those observations. This plays into our growing ability to construct an even more comprehensive digital twin of our physical system, monitoring any aspect that we need. To take full advantage of that digital twin and really extract the true business value, we have to take things a step farther. That next step means being able to react to situations in real time, consume field data, and perform meaningful analytics on the fly. To do this, you must be able to monitor the data coming in from those assets. From here, you can create intuitive and engaging visualizations, bringing geographic context to dashboards and reports, building data models that show the most pertinent information, and create dynamic analytical models or workflows to understand where our operations can be improved. This allows us to react to what's happening quickly. By taking that digital twin from static to live, we create the building blocks for a shared understanding of operations at all levels of our organization. IoT, or Internet of Things, is the increasingly interconnected network of sensors and devices that produce real-time information. It's estimated that approximately 80% of these sensors and data have a geospatial component. So while monitoring data feeds in real time is nothing new to the industry, these feeds are most often visualized in tabular form. This, however, inherently lacks a great deal of information that is critical to making more informed decisions and to operate at maximum efficiency. So for example, if someone is monitoring these data feeds in real time and sees a significant drop in production between two different wells, how do they know the location of well A versus well B? Response time could be significantly different if the two wells are a mile apart versus 20 miles apart. And knowing that pumper A is within 2 miles of a full tank, while pumper B is 10 miles away, you can save hundreds of miles and hours behind the windshield and improve your response times dramatically. Businesses of all types want to monitor, manage, and optimize their assets, whether that means managing a fleet of vehicles or allocating and tracking valuable production equipment. This, of course, leads to the ultimate goal for all E&Ps, which is operational efficiency. So what are some actual examples of this in the oil and gas industry? In the interest of time, we're just going to go through a few of these, but there are a couple worth highlighting. Real-time data about personnel location can be combined with information about the immediate environment around them to help keep personnel safe. We can gain insights from movement analytics and optimize staff and resource allocation. Pair this with SCADA or OSI Pi integrations for production monitoring. In operations, this allows us to apply pump by exception workflows and anomaly detection. In fleet logistics, we can understand where our equipment is and use geofencing to know when someone is on site and how long they've been there. Many organizations want to leverage contextual information to provide critical infrastructure by detecting and responding to near real time to locate and isolate areas of risk. In many cases, this has to do with tracking significant weather patterns or events, but other types of threats can be monitored as well. This leads to more intelligent infrastructure protection and allows us to develop on predictive maintenance. So what does this look like in practice? I like to reach back to my military experience where the command and control centers revolved around what's called a common operating picture. I like to describe this common operating picture as having those 4 monitors up on a wall. Those monitors give us all the information we need to know at any given time. The first monitor is dedicated to an accurate visualization of all our assets: well pads, facilities, pipelines, infrastructure, leasehold, etc. The second screen on the wall is where we bring the asset to life. Through SCADA and those OSI Pi feeds, we are monitoring everything that's happening in real time: tank batteries, production volumes, flow rates, personnel locations. This helps us more intelligently take action on things that are happening in the field. That'll take us to the third screen, responding to events and coordinating the movements of field personnel, from daily route optimization to emergency response, alarms, and of course, safety. And lastly, all this information comes together in the end to operationalize the data. This is where we can analyze all the data being collected and learn where we can improve to operate more efficiently and drive down costs. Whether that be time spent on pad, recognizing workers that are completing the most tasks, or predictive analytics and intelligent automation. In my experience, most oil and gas companies will already have an operations control center. But what I've realized is that a lot of those are not leveraging the power of location and spatial analysis. Across all these use cases, in order to really take advantage of the data being produced by the sensors and IoT devices, you need to be able to address 4 fundamental challenges. First, have the capability to ingest the huge amount of data being broadcasted by these armies of sensors, which in some industries such as oil and gas is coming in at higher and higher velocities. Second, you must be able to analyze that data as it's streaming in real time. This is how you derive important insights from this persistent stream of data. Third, you need to have the ability to create parameters that create alerts and trigger notifications as the data is coming in. And last, take action when necessary. So to meet these challenges, Esri designed a new solution specifically developed to meet these tasks and provide an intuitive framework for them, called ArcGIS Velocity. ArcGIS Velocity extends Esri's geospatial cloud with real-time and big data functionality as a cloud-native software as a service offering. It provides a wide variety of capabilities for ingesting and working with observations or sensor data. You can simply configure out-of-the-box connectors to bring in data from IoT platforms and third-party APIs. It's also an end-to-end system for analysis, supporting the consumption of data in real time, performing analysis in real time or near real time, and historically analyzing big data over time. Plus, you can take immediate action as a result of your analysis, sending alerts and notifications or triggering downstream processes, whether that be emails, SMS, or other notification systems. Now, one key characteristic here to get excited about is ArcGIS Velocity's scalability and resiliency. This stems from its Kubernetes container-driven architecture, which enables that compute to be distributed across parallel tasks and add to its resiliency. And last but certainly not least, it's fully managed by Esri, meaning you don't have to worry about the complexity of configuring and maintaining this extensive infrastructure in-house or on-premise. Now, while the technology side of ArcGIS Velocity is certainly impressive and exciting, personally, as someone who's not too technical, what I find most exciting is how intuitive and easy the solution is to use. With ArcGIS Velocity, you don't have to be a GIS or IT professional to make use of these tools. The simple web user interface is simple enough to empower any user within your business to perform their own analytical workflows and produce products that may be useful to their team. I want to hand it over to Matt Ballard, who's going to show us examples of this solution and show us just how easy it is to use. So I'll hand it over to Matt.
All right, thanks Baker for that introduction to just digital twins and ArcGIS Velocity and everything. Appreciate that. I'm going to be showing everybody here how ArcGIS Velocity, the product that Baker just introduced to us, helps you to build a digital twin of your operations. And in particular, we'll look at how it can integrate real-time data and then perform analysis on that data at scale. But first, I want to look at what a geospatial digital twin can look like. Now, whether you operate onshore or offshore, or if you work in upstream, midstream, or downstream, geospatial data is absolutely critical to your digital twin. Everything has a location. And here on my map, I can see leases, operating area boundaries, and as I zoom in, I start to see more information about roads, wells, well pads, tank batteries. So everything has a location, and of course, underpinning all of this is an imagery-based map, right? And that gives context to everything. But right now, this map that I'm looking at is static, right? This isn't live, and that's really a cornerstone of any good digital twin. And ArcGIS Velocity enables you to bring this map that we're looking at to life. So I just went and turned on 2 additional layers coming from ArcGIS Velocity. First, these blue dots represent the current locations of all of our workers in the field. Here I can click on them, see who it is, and quickly access their contact information. Second, I've also added a layer that shows me the locations of significant issues that need to be addressed. So for example, shown in red on the map are SCADA alarms. So if I go find that specific alarm that I've clicked on, it's indicating that this meter has a high tubing pressure. And that's something that we need to go out and address in the field. So all these data sources, whether they're static, infrequently being updated, or real-time ones like the ones we just added, they can all be combined together into a dashboard, right? And this is my geospatial digital twin in this case. On the left, I can see a summary of some of that location tracking data, such as the current status of all of these employees, whether they're on site or traveling, and then who it is and when they last reported. And I can also summarize that data, showing me things like the average time employees are spending at facilities, or keep a historical list of all site visits that have occurred. On the bottom, I see most recent weather information coming from weather stations out in the field, telling me information about wind direction, temperature, and that's really critical for employee health and safety, understanding the current environment and potential inclement weather. And then finally, the other source of information is coming from a SCADA system or sensors that are in the field monitoring equipment. That includes these alarms that you see on the map, symbolized as those red dots. And this could be showing things like well downtime, gas detection for methane or H2S, or really any other critical information that you're monitoring. Additionally, I can bring in production data, right? So if I go click on any of these wells, I'll instantly receive information about that well, its current status, month to date, and 24-hour production, normalized against 1,000-foot lateral, and then also percent liquid and percent gas. So really any information that you're collecting in the field can be streamed into a geospatial platform like this because everything has a location. And because everything has a location, all of these production metrics, for example, I can quickly do things like spatially filter by selecting leases. So if I select this lease, my 24-hour production metric shows me exactly how much has been produced in the last 24 hours inside of that lease. And the last thing that we've also mapped out are tank batteries. So if I zoom in, I can find those tank battery locations. And we can generate charts that show the current volumes of those tank batteries, in blue indicating current volume, and gray indicating remaining volume. And similarly, by selecting each of those, a chart can be generated showing me historical data for the current for the volumes of those tank batteries over time. So, everything that we're looking at here is what ArcGIS, and in particular what ArcGIS Velocity brings to any digital twin. I want to look now, though, now that we've seen what geospatial digital twin means, I want to go look at what ArcGIS Velocity is and how it makes this possible. So we're just going to walk through a couple of slides to introduce this product and how it works. ArcGIS Velocity, as Baker mentioned, is a capability of ArcGIS Online. So it is completely cloud hosted, and there's no need for servers or infrastructure that you manage. Esri manages the environment. And it comes with a web application, which you can see on my screen here. Inside of here, users have the ability to create 3 key items. And these are what we'll talk about today. First are feeds. Feeds are ways that you ingest real-time data, such as those vehicles or SCADA alarms that we saw. Second is real-time analytics. These analyze feeds as they come in, and this is what showed us earlier who is traveling versus who's on site and where they were. And then third is big data analytics. These analyze historical data in larger amounts of data at scale. So if you're dealing with thousands and millions and even billions of records, that's where big data analytics come into play. Ultimately, each of these are designed to help you address those key challenges that Baker mentioned of ingesting, alerting, and analyzing. Feeds, as I mentioned, they ingest and visualize real-time data streams. And configuring those in Velocity is a very simple and easy to use guided workflow that lets you connect to different external sources of data, things like IoT platforms, ArcGIS, web and messaging protocols like Kafka, and much more. These feeds, what they do is automatically derive the schema of the incoming data as it's being streamed to our platform, and then they allow you to revise that data model on the fly. And all you have to do once you've created those is simply add them to your web maps, and then you overlay it with all of your other GIS data, as we saw. And with Velocity, bringing in feeds is really the first step. Once you do that, you can start to layer in real-time analysis workflows. Here, the feed is an input to a process which can then transform, enrich, and analyze your data. And with these real-time analytics, they'll process each and every message from a feed continuously as they arrive. On top of this, you can use static data sources like well pads, such as we saw earlier, as geofences for enrichment or detecting when people enter them. And then over time, the output of these analysis workflows can be stored to things like feature layers, sent as notifications through SMS or email, and even actually sent out as commands or triggers to external systems to actuate behavior, right? So changing a downstream process and actually impacting something that's physically occurring. Real-time analytics, as I mentioned, take those input data sets, such as feeds and static data sources. We've got a variety of analytical tools that you can combine to build a pipeline for your data and then output to a variety of locations. So inputs, analysis, and outputs. And as far as data types that we support, we cover most major commercial IoT platforms as well as common real-time messaging technology. Just as an example of a couple, MQTT is a technology that can be used to act as a bridge between different systems. For example, to bring in vehicle tracking data from vendors like Geotab. And Azure IoT or AWS IoT Hub, these could be leveraged to access data from, for example, a SCADA system and stream it directly into Velocity in a completely secure manner, because of course we need to make sure SCADA systems are secure. And then pulling a website enables you to access really any number of sensor vendor APIs that are out there. So feeds bring in real-time data, real-time analytics, analyze that data, and then can store it over time in, for example, a feature layer. As data arrives, though, in real time, these historical data sets can grow to extremely large volumes. Just 250 messages a day, or a second, excuse me, grows to 20 million records in one day. And for that reason, Velocity is designed to grow with you using big data analytics. These can analyze data ad hoc, as well as in near real time. So maybe every 5 minutes, you would do a big data analysis, or over time, doing daily, weekly, annual analysis of billions of records. Similar to before, at a high level, we support a variety of input sources, cloud data stores, ArcGIS, and more. We have dozens of analytical tools, and then you finally output your data to one or more destinations. And here's just a quick sampling of some of the analysis tools that are available for you. This includes tools for summarizing data, detecting incidents, analyzing patterns, and quite a bit more. So now that we've seen what a geospatial digital twin is and how Velocity fits into it and what its key capabilities are, I want to go look now at a quick demonstration of the product. So as we've mentioned, ArcGIS Velocity is something that is a capability of ArcGIS Online. So to access the application, after you've added it to your ArcGIS Online subscription, you can quickly access it from your app launcher up here in the top right. This will take you to a very simple to use web application where users can author feeds and analytics. So you don't need to be an IT or GIS professional or an administrator of your environment to use this application. This is really designed to enable anybody to do this analysis. When you get into Velocity, the first thing that we need to do, right, is configure a feed to consume data. So I'll start by selecting Create Feed, and I've got those three options. So first, my data could be coming from ArcGIS. This would be things like a feature layer that mobile users are collecting, for example, inspection data into with mobile apps such as Survey123 or Quick Capture. And this could also be location tracking data coming from ArcGIS Field Maps, which is capturing locations every few seconds from mobile devices in the field. But it also works in places like offices and refineries. Then we've got access to different cloud options. So this includes Azure, AWS, Cisco, and these enable you to access any data that you're bringing into your cloud data platforms or warehouses. And then finally, we have a flexible set of web and messaging protocols like subscribing to a WebSocket, a Kafka broker, and much more. For today, though, I'm going to use the Azure option to connect to an Azure Event Hub. Here, what I need to do to connect is provide an access key name, an access key, an endpoint, and an entity path. These are all settings that you configure within Azure to stream data. So it's specific to this feed that we're looking at. ArcGIS Velocity will connect to that source of data, and then it will auto discover the schema of any incoming information. So you notice here it's sampled a couple of values. I can preview that data. I can remove fields, change their names, change data types, For example, I know this is a time field, so I'll change it from an integer to a date. Now, in order to make us, or to make this work within a map and for us to be able to use analysis tools on this data, I need to specify a couple of fields. First is my location, which in this case comes from an X and Y field, or longitude and latitude. And then I can pick from a vast coordinate system library to find my spatial reference. Next is a time field. I need to know when these events come in. So here I'll specify that I do have a time field and tell it which one that is. And then lastly, the track ID. This is a unique ID associated with each vehicle or asset that's being monitored. For vehicles, I could use a VIN number, or here I can use the driver's name in this case. And for AIS data, as another example, this would be an MMSI number. So unique ID associated with each asset. From there, I'll give my feed a name and complete it. It'll take just a few seconds for this to initialize, and then I can go show you what this looks like in a map. But in the background, what's happening is we're standing up resources to constantly listen for new data. These feeds are long-running jobs that are, again, hosted entirely in the cloud. And they'll continuously ingest incoming data, parse it based on the settings we just configured, and then enable it to be viewed in ArcGIS. Technically, what these feeds are visualized as are stream layers, which display new data in your web maps. So your web maps will never be stale. And once my feed is initialized, to view that data that I've configured, all I need to do is select this Open in Map Viewer button. I've already gone ahead, though, and configured a map to show us what this will look like. And here, now on my map, I can see vehicle locations. I can, again, click on them to see who it is and contact them. But if I zoom in, we can see a little bit more information. I can see where they're headed based on the vehicle's bearing, and I can see where they've been using this stream of past records. And using these well pads, I can even see where certain employees are. And of course, this one's simulated at a higher speed. So a map like this one is really invaluable to any remote operations center. I can respond to critical issues because I've also incorporated the SCADA alarms on my map, shown in red. I can coordinate work in the field because I know where everybody is and I can contact them instantly. And this helps me to run my operations smoothly and efficiently. But once I have my data in ArcGIS, this is really where you can start to do interesting and useful things with Velocity. And that's where we'll start talking about real-time analytics. As I zoom in, and we looked at this earlier, I can see well pads and I can see where people are. If I wanted to automatically do this analysis, though, instead of visually going in here to look at it, I could use real-time analytics, combine these two data sets together to alert people and tell people where workers are, whether they're traveling or whether they're at a facility. So to do this, I'll open up another tab and we can look at how you create real-time analytics. Again, from the ArcGIS Velocity homepage, I'll now select Create Real-Time Analytic. I get to choose from either an existing feed or a new feed. I'll choose existing because I know I just created one. I'll go select that and confirm my input data. Now, I'm going to jump over to another tab where I've already started this, and I've opened up the model view. So the model view is really useful because you can graphically connect different inputs and analytical tools and build your workflows. So as mentioned, I want to identify when employees from this vehicle location feed enter well pads. So I've already brought in my feed. The next step is to bring in those well pads. Here, I'll search my organization for any GIS data that's out there and quickly add it to my workflow. I can filter data down, remove fields that aren't necessary, and specify a couple of attributes. So far, we've brought in a feed. We've brought in source data, like reference data, like well pads. And the next step is to do an analysis. Here at the top right, I've got tools for data enrichment, finding locations, managing data, and in this case, summarizing data. I know that this join features tool is what I need to use to find who's at which facilities or who's traveling. All I need to do is connect these two inputs to the tool, and then I can configure a number of settings. Now, I happen to know I need to do a one-to-one join operation. I know that I need to retain all features regardless of the join result, and it's a spatial intersection. Now, this is really the benefit of Velocity in this case because you can be iterative with your analysis. So I happen to know my settings there, but as you're working with it, it's very easy to change these settings, visualize the output, and iteratively build your models. The last thing I want to do is add a pad, add a summary field for which pad these people, or these vehicles in this case, are intersecting. So we'll call it well pad name. This field is going to tell me who it is and which facility or if they're traveling. Once I'm done, I'll apply that. And now with my two inputs, my analysis process, the last thing I need to do is provide an output. I'll select outputs and I can choose a new feature layer. This new feature layer, then I can choose a couple of data storage options and again, give it a name. So once I've done that, inputs, processes, and outputs, I can save my analysis tool and press start up at the top right. Now, I've already gone ahead and configured another one because the one that we looked at is very simple, but just to show you some of the extensibility, you can really go much further than what we just looked at. So to summarize this one, I'm doing the exact same workflow and outputting to a layer called geofence status. But I've also added another process. I added our detect incidents tool. What this one does, it will alert you to only the first time that somebody enters a facility. And we can then use that to send an email notification. So now I have both a layer that can be viewed in a map, as well as I'm sending notifications when people enter areas of interest. And as I go visualize this on a dashboard, I can see the outputs of this analysis. At the top left, current employee statuses are shown. I can see who it is, what site they're at, and what time they last reported. And I can be receiving those email notifications when people enter specific areas of interest. So to summarize what we've seen so far, before we look at the last component, we saw how Velocity enables you to rapidly ingest live data with feeds. Then using real-time analytics, you can perform real-time geospatial analysis on those data feeds and turn your data into valuable information. The last thing that we're going to look at is big data analytics. This is the third capability of ArcGIS Velocity. Taking, for example, these vehicle feeds that we've captured over the course of the day with 100 trucks in a fleet and capturing locations every few seconds, you can easily start to generate more than 1 million points every day. And I've gone ahead and added those to my map here. ArcGIS Velocity gives you a way to visualize big data like that by dynamically aggregating that into bins. So here I see those bins updating as I zoom in. And if I zoom in to a certain level, I'll actually start to see the points that show me where people have been. With all of this GPS data, there's a couple of things that we can do with it, right? First, I could look at information like how many vehicles are being utilized in our fleet, and if there's an opportunity to reduce or if there's a need to increase the size of our fleet and save on costs. Or I could look at how many miles employees are driving over time and identify opportunities to possibly save on costs by reducing driving times or windshield time. Now, to calculate the mileages that are shown here in this chart, we won't look at it today, but I could use some of the out-of-the-box tools in Velocity for calculating journeys and distances traveled. Using the same data, though, I could also create a list of every single facility that's been visited and ensure that no facility isn't being visited within a certain time frame. So to explain what I mean there, here on the map, I can see all of these well pads are now colored based on when they were last visited. So I can see a couple of red ones down here. If I click on those, it'll tell me within what time frame they were last visited. So here, the last visit date was 2 weeks ago. And if I click on one of these orange ones up here, this one is visited 1 week ago. And then everything that's green has been visited this week. So for many operators that we work with, their goal is to visit every single facility within a day or within a week. And this is a way that you can track against that goal and make sure that you're hitting it, and also addressing any potential issues, right? So anything that hasn't been visited in 2 weeks, we need to go out there and ensure that it's environmentally sound and operating efficiently. And so for a dispatcher or somebody managing a workforce, they could use this layer to efficiently dispatch employees. So to show how we did this, I'm going to open up ArcGIS Velocity again, and we're not going to walk through this whole workflow, but at a high level, what we're doing is I've brought in historical GPS data, well pads, and operating areas. Using those well pads and historical GPS data, I can aggregate those together to show me whether or not a GPS point fell on a well pad. If it did, we can assume that it was visited. If it didn't, we can assume that it wasn't visited. The output of that is then saved to a layer called daily site visits. Now, on top of that, organizations, like I said, have goals of maybe 100% of sites every week or 90% every week. And that's where we're using this analysis down here at the bottom to create a layer called visit rates. This will summarize what percentage of sites were visited every single day. And we can use that to create charts back on my dashboard, such as this one on the top left. Here it shows me thresholds. Green is good, yellow is okay, red is bad. And for each of these 3 operating areas, I can see how they're tracking against our goal of visiting a majority of sites every single week. Here, this one's on the decline. This operating area is staying fairly steady, and this one is on the increase. So this is how you take, feeds that collect historical data, and this is how you can take big data analytics and actually turn it to valuable information that can drive, business decisions, for example, about how to allocate resources. So just to summarize everything that we've looked at here in a quick slide before I hand it back over to Baker. ArcGIS Velocity, as you've seen today, is a real-time and big data capability of Esri's geospatial cloud. At a high level, it has 3 key capabilities of feeds, real-time analytics, and big data analytics. This enables you to ingest data and then analyze it in real time and over time. And then this is really designed to be flexible and extensive, right? This is not limited to specific workflows, right? We showed you a couple in operations, but it's designed to be very flexible and extensive, and it can support really any number of business use cases. In today's demonstration, we saw how it was applied to fleet tracking, mileage analysis, infrastructure monitoring, but really this is just a small sample of how you can leverage these tools. So with that, I'm going to pass it back over to Baker to close out the webinar before the question and answer session.
Thanks, Matt. That was awesome stuff. It's always the best part of the webinar to actually see it in action. But now the next part we need to talk about is how we're going to get started on all this. Commonly, what we've been seeing with our customer base so far is that we're starting small with little proof of concepts and little prototypes. But from there, the scale and number of use cases are quickly growing. So we're moving on to pilots and even going into full grade production solutions. Given that ArcGIS Velocity is scalable, it allows you to start immediately. So whatever the size of that operation might be, no matter if it's just a small few batch of fleet vehicles or tens of thousands, hundreds of thousands of wells. Now, of course, every organization is going to be unique, but the solution is flexible. So in that sense, I really encourage you to get in touch with your Esri rep. They're going to be able to talk with you, collaborate, understand your specific needs for your organization, and then recommend the appropriate approach or the appropriate workflow to get started on. So as always, the Esri team is here to help you, and we want to make sure this is a success. So get in contact with us, and we'll help you bring this to production at your organization. With that, we have time for questions. So I'll open it up. Tiffany, do you have some questions already from the question room here?
I do. We have a active audience, and so we'll get into the questions. The first question I have is, do you have the interfaces with different SCADA companies to hook up their data outputs, either to RTUs or to meters, etc., such as Signet?
Yeah, I can take that question. So with Velocity, we've designed it to be very extensible in that we're not locked down to specific providers or specific connectors to certain solutions, but instead we provide interfaces with those cloud IoT platforms like Azure and AWS, or those common real-time messaging technologies. So think of those technologies as a bridge to connect to really any system that can send data or that can capture data in the field, right? That's really the goal with Velocity, is to keep it generic and enable you to really bring in through those key intermediate workflows.
Thanks, Matt. Next question. Can you connect or bring the data into Spotfire?
Yeah, with Spotfire, there are mapping capabilities, and this is probably a good topic to take offline in the conversation with you, but their mapping capabilities typically are limited to unsecured WMS services is some of what I've seen. There isn't a WMS service or a web mapping service, ArcGIS Velocity, that's available. I think if you're looking to bring it into a BI tool, for example, Esri has different ways of visualizing that type of data that can maybe supplement some of the workflows you're doing in Spotfire, or you could also look at Power BI. But for Spotfire, I don't think that there's a lot there today. Out of the box, at least. I know Spotfire could be customized, and maybe there's opportunity there, but to make something custom, but not out of the box.
All right. What out of the box connectors brings the application? In other words, with which real-time data transmission systems are compatible with ArcGIS Velocity?
Matt, I believe you had a slide on that.
Yeah. If we were thinking of that sort of previous, I can open up that slide about supported inputs and things like that. And it's sort of related to that earlier question about the different specific SCADA companies. It's essentially, we try to keep it as open and generic as possible, supporting cloud IoT platforms and the most common real-time messaging technologies out there, as well as having an API within our own platform. So you could write your own application to send data to Velocity. So we try to keep it as generic as possible to support as many solutions are out there. Yeah.
Next question. Is there data capabilities for the data to reside in the operator's enterprise database? Are there FISMA, federal regulations on what data can be shared and where it can reside?
Velocity today is only available as a software as a service, so it's going to be cloud-based Esri's databases. But in the future, as we roll out ArcGIS Enterprise on Kubernetes, we will eventually have a Velocity that can be put in your own environment, and so you can look forward to that in the future. But today, it can't reside in your own enterprise database.
To kind of piggyback on that question, since ArcGIS Velocity sits on ArcGIS Online, how can it integrate with someone's enterprise portal environment?
Yeah, that's a good question. So yeah, while you can't have your data necessarily live, you can't, how you saw those aggregated vehicle tracks, you can't necessarily do that in your own enterprise database, but you can use your enterprise data as inputs into Velocity. So say you want to use those well pads, for example, as geofences, but that's in your on-premise database. That can be brought into ArcGIS Velocity, even though it's not software as a service. That's fine. And there are ways for you to get data out of Velocity through some sort of an ETL process to extract that data and load it into your enterprise environment. So there are ways to work together, and it's worth having a conversation if you're interested.
Okay. How is this licensed?
Of course. So do you want to take it, Matt?
Yeah, I can take a quick swing at it. It's essentially two things to think about with licensing. When it comes to the capabilities, they're organization-wide, and they're ArcGIS Online. So it's an annual subscription, and it's depending on how many use cases or how much data and analysis you need to do. There's different tiers that it can be scaled up to fit essentially your specific requirements. Whether it's 1,000 vehicles that you're trying to track and analyze in real time, or if it's 50 and you're trying to do much smaller analysis, it can be paired to your specifics. From a user perspective, the capability to create everything I did today is for creators. You don't need like a special Velocity per user license, and the outputs can be viewed by everybody. Again, you don't need a viewer with access to Velocity. The outputs are just able to be accessed by everybody. So that's how I would summarize the licensing.
Thanks, Matt. On the data connection setup for the data coming in, can we use our own custom projections?
So you have access to all the different coordinate systems that are available within ArcGIS traditionally. So hundreds of those that are available. If you have a local coordinate system that's not well known, that would not be something necessarily that would work out of the box. There's ways that we could probably work with you to make something happen, though. Again, another thing to take offline to understand your specifics.
Okay. Can this be used to bring in types of information for different departments? Like I work with land and deal with the contracts and need to know lease and surface information. Can we bring in that information from our quorum system and third-party information? There's also a added question to that. Also, can we pull in Excel reports out from that information for a given area?
Yeah, land data, absolutely, is something that can be brought in. If it's available as one of those supported input types, which it probably is in some capacity, it can definitely be brought in, analyzed, and exported, for example, in a format that you could view in, for example, ArcGIS Maps for Office. So you can view it in Excel with an embedded map, and even export some data to something that could be brought into a spreadsheet. Yeah.
Next question. Thank you for your presentation. How must data be structured to bring out this kind of display? So he was referring to for geofencing.
Say that again?
Okay.
So the question is, how must the data be structured to bring out this kind of display, maybe for geofencing?
I would say the key thing is your data just has to have a location. That's the most important thing when it comes to your data structure. Any number of attributes. The key thing is just making sure, especially for geofencing, that you've got locations, because that's fundamental to the workflow. That's the one thing I would say there. But yeah.
Yeah, so I guess Matt was just using a polygon feature class that represented as well pads and made those into geofences.
Okay. We have a few more questions. Is Velocity a single tenant or multi-tenant solution?
Good question.
It's offered as both single and multi-tenant. environments.
Okay. So what is the roadmap for GeoEvent now? Off to pasture? Question mark.
Could have seen that one coming, Matt.
Yeah, it's not going away because ArcGIS Velocity is very reliant on this Kubernetes architecture because of its scalability. It's not something that is going to be able to go back and replace our traditional on-premise enterprise. So the two products are going to remain, and the same teams are involved with both of them. And so, yeah, GeoEvent's not going away, at least anytime in the near term, and anything I'm aware of.
All right. What are some examples you see of this being used for companies that only operate offshore?
One of the examples I had in the slide of the industry use cases was the AIS, ship tracking. That was one of our use cases, and I think there was a demonstration at UC, Matt, about that workflow.
Yeah. At some of our user conferences, we've had some recordings of different AIS workflows that you can do with big data and the ArcGIS platform. I think AIS is definitely the biggest one when it comes to offshore, as well as looking at helicopters. So, understanding how far a helicopter is from its final destination, understanding where weather events might be intercepting or interfering with your operations. And that's a big one. The concept of weather and real-time weather data is really critical to this. You might look offshore at inclement weather like lightning strikes, and understanding where those are within a certain distance of your operations, that might impact what work is able to get done. So thinking about weather, AIS, helicopters, those are all really common data sources that feed into workflows offshore.
What sort of stress testing have you done? Is there a maximum, events, seconds? What happens to data if maximum ingest capacity is exceeded?
Yes, so it is not unlimited. So it's a really great point. It is something that has finite resources associated with it. It can get scaled up to a very large capacity, though. The specifics of that are difficult to say because it varies depending on the type of data that you're working with, right? The number of attributes, the complexity of the data that's inside of those attributes as they come in, as well as the type of analysis that you do. That geofencing workflow is very simple, but if you wanted to do something much more complex, it would take up more resources. So this is where we want to talk with you about your workflows, make sure we appropriately size the environment to your requirements. What I can say is that we have load tested this environment, up to over, I won't give specifics, I guess, because it is difficult to say, but over tens of thousands of events per second. So it is very scalable.
Matt, I was going to say our dedicated environment is up to roughly 10,000 events per second. So, and as you mentioned, tested over that.
Yeah. And then, of course, just always very dependent on the workflow, because the data could be a lot bigger, for example.
Okay. Next question. Can this be integrated into 3D visualization?
Yeah, there's ways that you can look at it in 3D. There's definitely ways to do that. I think it's going to be a little bit more limited than 2D, but it is doable, though, to do that.
Okay. Can we integrate our own real-time projections for propane usage at a location? We do not currently have real-time sensors installed, but instead use a projection system to determine when a location may need a delivery.
Oh, okay.
Oh, you got it?
I was just going to clarify, a projection system is then you have a software that's projecting when something needs to occur.
That's what it looks like
Yeah.
based on the question. I mean, it says
Okay.
projection system, but it says to determine when a location may need. And he said yes, correct. So yes.
Okay.
Yeah.
Want to make sure we weren't talking about map projections.
Yeah, I think there's definitely ways to make something happen there. I think it's an interesting use case that we want to understand the specifics of. So a good offline conversation, I think. But I can definitely imagine some possibilities of doing that. Yeah.
And I guess I'll have this last one. I think we covered almost every single one of them. Can you easily bring in data into a map if it's in a spreadsheet and also have it automated to update the map?
Yeah, that is a workflow that's doable. I think depending on the specifics of it, you might even be able to find a solution outside of Velocity to do that if it's a spreadsheet. I think it will, automating things with like tools like FME or Python. I'm not sure if a spreadsheet would be the best input to Velocity, but there's ways that we can make it work. Again, something to talk about.
All right. Well, thanks. That's about the end of our time. So I want to thank everyone for your questions, and thank you, Tiffany, for helping us out here. If you have more questions, please, again, feel free to reach out. And you will be sent a survey after this webinar. So I really encourage you to fill out that survey. It helps us understand what you're interested in learning about and improve on future webinars. So please take some time to fill out the survey. And thank you for joining, and talk to you all again soon. Thanks.